We will start the second part of the fourth chapter of networking series. So, computer networking fourth chapter is network layer, and it is the fourth layer in the OSI model. Network layer, network layer is the third layer in the OSI model. So, today we will start from the hub. So hubs are fundamental network devices that link multiple LAN devices, broadcasting income data packets to all connected devices, potentially causing collision. So basically, a hub is a device, is a multiple that link multiple LAN devices and broadcasting income data packets to all the connected devices, potentially causing to all connected device connected to all device, potentially causing collision. Use case simple and inexpensive but largely obsolete, replaced by switches in a modern networks. So third one is bridge. Bridge connect LAN segments, filter traffic based on a MAC address, and reduces collision by dividing the network into smaller domain at the data link layer. So this is what bridges does. Bridges do. So I hope you understood what bridges do actually. So let's see the use cases. Connecting different parts of the network, especially when using different types of cables or media. Then we have switches. Switches advance at the data link layer, create separate collision domains for each port, forwarding data only to the intended destination device based on the MAC addresses. So switches are advanced at the data link layer. Create separate collision domain for each port. Separate collision domain for each port. Forwarding data only. Forwarding data only to the intended destination. To the intended destination device based on the MAC addresses. Based on the MAC addresses. Use cases. Core component of the modern LAN. Core component of the modern LAN. Improving networking efficiently and reducing collisions. So this is the use case of the switches. Then we have router. In router, we have in routers are located at the network layer, forward data packets between networks, utilizing IP addresses to determine the optimal path for data delivery. What is the use case of router? Router, the connecting different networks such as home network to internet. This is the use case of router. Then we have gateways. Gateways act as translators between different networks, just networks, protocols, or architectures. They operate at a multiple. And so now we have the use cases network connecting a network that uses one protocol TCP/IP with another that uses a different protocol. Addressing is critical at the network layer to identify devices that ensure data reaches the the correct destination. Internet addresses. An IP address is the hierarchical number assigned to each device on a on a network identified uniquely within the network. IPv4 addresses are 32-bit numerical labels typically expressed in a dot decimal notation. So after addressing we have classical addressing, internet addressing. We saw internet addressing. Now we will have classical addressing. So let's again see the addressing, like internet addressing. Addressing is a critical network layer to identify devices and ensure data reaches the correct destination. So, what is Internet addressing? Internet addressing, an IP address is a hierarchical number assigned to each device on a network. Identify it uniquely within the network. IPv4 addresses are 32-bit numerical labels, typically expressed in a dot decimal notation. So the second one is classical addressing. In the early internet, IP addresses were categorized into classes A, B, C, D, E based on the network size, with the class A having a larger number of host addresses, limitation in efficient use of the IP addresses leading to the development of classless inter-domain routing, CD, CIDR. Then we have routing. Routing determines the path data takes from source to destination across interconnected network. Two main types of routing, that is static routing and dynamic routing. So first one is static routing. Let's see what is static routing. Static routing involves network administrator manually configuring routes, with the routing table remaining fixed unless manually updated. Second one is advantages and disadvantages. So simple and secure with no routing overhead in advantages. Then disadvantages, not flexible. Any network change requires manual updates. So let's see dynamic routing. So after seeing the advantages and disadvantages of static routing, we have dynamic routing. Dynamic routing involves routing updated their routing tables based on the network topology changes using protocols like RIP, OSPF, or BGP. So the advantage of dynamic routing is that it adapts to network changes, automatically finds the best route, and the disadvantages introduces routing overhead. It's more complex to configure. Routing techniques. There are some routing techniques like distance vector routing, link state routing, path vector routing, etc. So let's see one by one. At first, distance vector routing. The function of distance vector routing is routers used algorithms like RIP to calculate the best route based on the distance to the destination. Each route shares its routing table with its neighbors, and there is some limitation in distance vector routing. The limitations is a prone to routing loops and slow convergence, low convergence in large networks. Then we have link state routing. Routers create a comprehensive network topology map and the algorithms like OSPF and determine the shortest path to each destination. And there is some advantages in link state routing. It's faster convergence and more accurate routing information. Then we have path vector routing. The function BGP employs path vector routing to track data back, mm, patterns and prevent routing loop commonly used in the inter-domain routing between different autonomous systems. The use cases of this type of routing is routing between large network like ISPF. Then we have protocols. Let's see some protocols. The IP protocol or Internet protocol. The function is IPv4 is a widely used protocol for routing data across the internet, responsible for addressing and packets between hosts. Widely used protocol routing data across the internet, responsible for addressing and packets between hosts. Limitation: IPv4 addresses are limited to 32-bit, leading to address extension. We have IPv4. Internet Protocol version 6. IPv4 is the successor to IPv4, offering a larger address space. to enhance security auto configuration and improve the routing efficiently and adaptation. IPv4 adoption has been gradual, with dual stack implementation IPv4 and IPv6 becoming common as the network transitions and IPv network transitions to IPv6. Understanding these topics is crucial for efficient data routing management and communication across diverse networks, ensuring seamless connectivity environments. Connectivity in complex and diverse networking environments. So this is all for this chapter. Hope you like this video and enjoy this video. So if you did, then give a thumbs up, subscribe to my channel, and stay with us. Keep supporting. Stay tuned. Keep watching. See you in the next video in the chapter 6. Sorry, in the chapter 5 of computer networking. So thank you for watching. Goodbye.